Hello everyone, welcome back to this video lecture on replacement analysis. So in the first part of this series, on the first part of this replacement analysis, we have seen how calculations regarding replacement can be made and decision pertaining to whether the replacement is desirable or not, that decision we can take, and if the replacement is desirable, what is the appropriate time of that change or that replacement must be must be there. Now let us see some more examples on replacement analysis. So these are the slides which we have discussed earlier in our part 1 lecture. Now coming on to a problem, say for example, if this is a given problem where a grinder was purchased 3 years ago for $40,000. It has provided adequate service, but an improved version is now available for $35,000. That will reduce the operating cost and cut expenses and cut inspection expenses. So this is cost and salvage value. So cost and salvage value. So the cost and salvage values for the two machines, they are given in this table. Costs that are same for either machine are not included. Also the operating costs for the Challengers are very low due to warranted equipment. So comparatively, if we just compare these costs, so these operating costs are comparatively lower as compared to that of the Defender because this equipment is under warranty. So based on the calculations, we have to decide should a replacement be made if the minimum attractive rate of return is 15% and the service of the grinder will be needed only for 4 more years. Now let us see how to solve it. So the very first thing, since whenever we are talking of replacement, we are making calculation starting from time t equal to 0 till the economic life or till the time period for which the services are desired. Now in this particular case, the equipment was purchased 3 years ago. So though this data is given, but this data will not be used in as far as the computations are concerned. Okay. So now let's see, first of all, whether we should answer whether the replacement should be made or not. So first we draw the cash flow diagrams for the Defender and for the Challenger. If we just focus on the Defender first, so the first cost of the Defender, that is at year 0, will be $12,000. The annual operating expenses, they are given like this, and at the end of the economic life, the salvage value for the Defender is given as $1,000. Again, in my previous lecture, I have told you that these salvage values, we can use these values maybe as the purchase price or maybe as the resale price depending upon the situation. So in this case, since we are purchasing this equipment at this point of time, so the first cost will be $12,000. So here in this case, we are using this salvage value as the first cost of the equipment of the Defender, and once the economic life or the useful period is over, that is of 4 years, the salvage value we will be using as 1000. So we are using an arrow downward, that is the first cost, and for the same salvage value we are using $1,000 cash flow as an upward arrow, as this is the resale value of the equipment. So if I just draw the cash flow diagram, so this is the first cost, that is 12,000, or the purchase price at this point of time. So whatever has happened earlier, we are not taking this into consideration because the equipment was purchased 3 years ago, but that data is fictitious because we are just focusing on the present time, that is t equal to 0. So this is the salvage value given. The first year of operating cost is given, the second year operating cost is given, the third year operating cost is given, the fourth year operating cost is given, and then the end of the fourth year, the equipment or this Defender can be salvaged for a value of $1,000. So if I just compute the EAC for this Defender by using the relationship between P and A or F and A, whatever we have discussed in our earlier classes. So what I have done, I have converted all these transactions into present point of time. If I have converted this into present, so treating this as future worth and converting this into present, f upon 1 plus I to the power n, similarly this, And again, once I compute the present worth, I am transferring this present worth in terms of annuities by multiplying with this factor. So if I compute the EAC for the Defender, in this case, this comes out to be $8252. On similar lines, if we compute the EAC values for the Challenger, where the Challenger economic life is given as 6 years. So again, if we focus on the data pertaining to Challenger, the purchase price is given as 35,000. So these are the annual expenses, and at the end of 6 years of economic life, it is salvaged for a value of $15,000. So if I just draw the cash flow diagram for 6 years, and if I compute the EAC of the Challengers on the similar lines, first converting all these transactions into present. So first of all, converting all these transactions into present, and then from present worth we can compute what will be the annuities. So again, if I see the EAC for the Challenger is coming out to be $8774. Now an important question here is that if we see what is being asked, that the services of the grinder will be needed for 4 more years only. That means in any case we have to focus on the Challenger up to year 4. Though what we did in this case, we have calculated the EAC by taking into account the economic life to be 6 years, which is not wise enough. So what we have to do, we have to just truncate this cash flow for up to 4 years in this particular case of the Challenger. So if I just truncate it for 4 years, so what will happen, these two cash flows, they will not be there, and the salvage value at the end of fourth year will be, at the end of 4th year, the salvage value will be $20,000. So this can be shown by an arrow upward in the cash flow diagram. So if I just compute the EAC for the Challenger for the time period for which the services are being required, so this is the cash flow diagram for the Challenger, and if I just compute it, the EAC values, this comes out to be 9157. Now in this case, if we see here, if we just compare, even though the EAC of the Defender is coming out to be less than that of the Challenger, even if we are taking this the time period for this Challenger to be 6 years, so the Defender need not to be replaced, but a better comparison is there if we just take into account the economic life of the Challenger to be 4 years only. So if we take the economic life of the Challenger to be 4 years, so again if we compute the EAC for the Challenger, this is coming out to be 9157. So again the thing is that if we just compare, if we make so what is the meaning of this calculation? That it simply means that if we are making this replacement now, that is at time t equal to 0, so the EAC for the Defender for the remaining service, it's come out to be $8252, while that of the Challenger it is 9175. So since the EAC for the Defender is less, so we need not to replace this Challenger at this particular point of time, that is at t equal to 0 or at the beginning of year 1. Now the other possibilities are, we can replace this Challenger at the beginning of year 1, or at the beginning of second, at the beginning of year 2, third at the beginning of year 3, and fourth at the beginning of year 4. So the overall decision is that if we just compare these two cash flows, that means that replacement is not desirable. Let us see year by year comparison whether the same result is coming out or not. So say if this Defender is replaced at the beginning of year 2. So this is what we have done. This is at the beginning of year 1, that is at the present point of time. So this is the beginning of year 1, this is end of year 1. So beginning of year 1 means at time t equal to 0. So whatever we have computed this, it means if we are making the replacement right now, that is at time t equal to 0, or in other words we can say at beginning of year 1. So based on these two values, at the beginning of year 1, the replacement is not desirable as the EAC of the Defender is less as compared to that of the Challenger. Now if we replace the same equipment at the beginning of year 2, let us see how the cash flow is being modified. So for the Defender, if the replacement is made at the beginning of year 2, let us look at the data. So if the replacement is being done for the Defender at the beginning of year 2, that means the same Defender will now be available for $7,000. The first year operating expenses will be $3,900. The second year operating expenses will be $4,600. The the last year expenses will be $5,600, and the last year the salvage value of the Defender is 1000. So if I use this data, so here the important thing is that when we are making a replacement at the beginning of year 2, that means we are replacing it somewhere here. So the same equipment is available for 7,000 rupees. Instead, what we have taken earlier into account, that is $12,000. So again, if we just plot it, so the first price is given as $7,000. The first year operating expenses is 3,900. Second year operating expenses is 4,600. The last year operating expenses is 5,600, and the salvage value is given as 1,000. So if I just compute the EAC of this cash flow, or the EAC of the Defender comes out to be $7399. Now when it comes to Challenger, so though we are replacing the Defender at the beginning of year 2, but we have to purchase this Defender right at time t equal to 0. That means, though when we are making this replacement at the beginning of year 2, it simply means that we have to operate the Challenger for year 2, for year 3, and for year 4. That means this Challenger is to be operated for year 2. So this is year 2, starting point of year 2 is this is the end point of year 2, this is the, or we can say this is the second year. The third year, the starting point of year third is this one, this is the end point of year third, or we can say that this duration is year 3. Similarly for fourth, this is the starting point of fourth year, and this is the end point for fourth year, and this is the fourth year. We can say that this is the duration of fourth year. Now again we are using this Defender for year 2, for year 3, and for year 4, but the purchase is to be made right now. That means for the first year we will be using data which is given at the start. For the second year we will be using the data which is given for the first year. For the third year we will be using for the data which is given for the second year, and for the fourth year we will be using data which is given for the third year. So that is why I have shown this in red. So for this we will be using the data what is being given at time t equal to 0. This is for the second year, for the end of year 1, or for the end of year 1 or beginning of for the end of year 2 we will be using the data which is given for year 1. So at the for the third year, the end of third year, the data which we will be using is the data pertaining to year 2. Similarly, at the end of third year or at the end of fourth year, the data we will be using pertains to the third year data. So again, if we see for the first year, the data which we will be using, or for the beginning of year 2, the data which we will be using is the data given at time t equal to 0. So time t equal to 0. So this is the first year, this is the second year, and this is the third year. So we have to operate the equipment for second year, third year, and fourth year. If I simply write it like this, so this will be data, because the replacement is being done at the beginning of year 2. So this will be data which will be used for year 2. This will be data which is used for year 3, and this will be data which will be used for year 4. So the thing is, whenever we are making the computations for the Challenger, we have to use the data starting from the beginning and up to that point for which we are using this equipment. Since we are using this equipment for year 4 and we are purchasing it at the beginning of year 2, so this will be the data this data will be used for year 2, this will be used for year 3, and this will be used for year 4. Let us see. So the first price is given as 35. So if again, so this will be the first price, so this will be the first price, so this we will be using for 0, this is at 1, this is at 2. So this will be at 0, this will be at 0, this will be at 1, this will be at 2, and this will be at 3. So the thing is, the same data we have used. this data, if I just draw the cash flow, so this will be the first cost. This is the first year operating expenses, second year operating expenses, and the last year operating expenses, and this will be the salvage value. So again, if I see this, I remove it. So this is for the at point t equal to 0, t equal to 1, t equal to 2. So a better way of writing this is, just for your understanding, so if I just, instead of writing 2, 3 and 4, if I just write it like this will be used for 0, this will be used for 1, this will be used for 2, this will be used for 3. So this is first year, this will be second year, and this will be the third year of operation. So the thing is that once we purchase it, so first year of operation, this is the first year, so in this case this will be used for as a second year data, this will be used as a third year data, and this will be used as a fourth year data. So if I just plot it on the cash flow, so the first price is given as 35,000. Operating expenses first year, second year, third year. So operating expenses first year, second year, third year, and the salvage value at the end of third year is given as $24,000. So again, if I make calculations, if I calculate the EAC using this data, so EAC, transferring all these transactions into present and then converting this present into annuities, we will see that the EAC of the Challenger is coming out to be 9170. So even if we are making a replacement at the end of year 2, and if we just compare the Defender and the Challenger, the cost of operation of the operational cost of the Defender is less as compared to that of the Challenger. That means no replacement is not desirable at this point of time. Now if we are making a replacement at the beginning of year 3, so for Defender it is quite simple. So once we are making the replacement at the beginning of year 3, that means we will be using the data pertaining to 2, 3 and 4. So if we are making a replacement at the beginning of year 3, so this will be the first cost, this will be the first year operating expense, this will be the second year operating expense, and this will be the salvage value. So this is the first year operating expenses, this is the second year operating expenses, and this is the salvage value. So if I just compute the EAC for the Defender, this comes out to be 7061. Now again for the Challenger, since we are replacing it at the beginning of year 3, that means we have to continue with this Defender for 2 years, that is for year 3 and for year 4. That means we will be using data which is for the 2 years starting from the top. That means first year and second year. Now we won't be using this data. The last row we won't be using. So if I just erase it, so this year data in the second computations, we won't be using this year data, because now we have to, the services of the Challengers are required just for 2 more years, that is for the third year and for the fourth year. So we have to make a purchase here. So this is the first year of operation and this is the second year of operation. So the first cost will be 35,000. The first year operating expenses will be $200. The second year operating expenses will be $1,000, and the salvage value at the end of the second year will be $2,700. So if I just plot it, this is the first year of operation, second year of operation, first year's so this is the first cost, first year of operation, second year of operation, and this is the salvage value. So if I just compute the EAC values, 35,200 We are just transferring this in the to the present point of time, transferring this transaction to the present point of time, this one to the present point of time, and then converting all these things into annuities. So if we just compare the two, that if we are replacing the equipment at the beginning of year 3, and if we see the EAC again is coming out to be less as compared to that of the challenger, so again the decision is no. Now the last part, if the replacement is being done at the beginning of year 4. So if the replacement is done at the beginning of year 4, so this is the beginning of year 4, this is at the end of year 4. If we just see the data once again for the Defender. So for the Defender, the purchase price now in this case, when we are making a replacement at the beginning of year 4, will be $2,500. The first year operational expenses will be $5,600, and the salvage value will be $1,000. So if we just plot this and compute the EAC values, this is coming out to be 7457. Now when it comes to challenger, that means we are making the replacement at the beginning of year 4. That means we will be using Defender just for one more year, that is for the 4th year. Now if again we see the table, now in this case, since we have to use the Defender only for one more year, so in this case we won't be using this data. Only since one services are required for one more year, so the same challenger can be purchased. The same challenger can be purchased for $35,000, and at the first year of operation it will be salvaged for $30,000 with a operating expenses of a year is 200. If I just plot this as a cash flow diagram, so this is the cash flow diagram. 35,000 first year operating expenses for a year is given as 200, and the salvage value is given as 30,000. So if we compute the EAC value on similar lines, it comes out to be $10450. So if we just compare the two, again the decision is no. So the thing is that although if we just compare the overall conclusions in the beginning, when we are comparing the overall EAC values of the challenger and the Defender for 4-year economic life, the EAC value for the Defender is coming out to be less as compared to that of the challenger, and that is being corroborated if we compute the EAC values according to the replacement at the beginning of each year. So if we see that the overall decision is coming out to be that the replacement is not desirable. So that is what we are getting when we are making the computations only for 4 years for which the services of the grinder is required. So this is all about the replacement analysis. So thank you very much.